Formative exercise 2.2, questions number 1. Differentiate each of the following expressions with respect to x. Questions A. I can write this part as 9x squared minus 3x to the power of negative 2. When we differentiate this, we're going to get 18x plus 6x to the power of negative 3. This is also the same as 18x plus 6 over x cubed. Questions B. I can write this as 6x to the power of negative 3 minus x to the power of negative 1 plus 8. Differentiate this, you're going to get negative 18x to the power of negative 4 plus x to the power of negative 2. This is the same as negative 18 over x to the power of 4 plus 1 over x squared. Question C. For this part, I can write this as 5x plus 4x to the power of 1 over 2 minus 7. Differentiate this, you're going to get 5 plus 2x to the power of negative 1 over 2, which is the same as 2 over x to the power of 1 over 2. Then I can write this as 2 over square root of x. Questions D. For this part, I can write this as 10x to the power of negative 1 over 2 plus 3x to the power of negative 1 over 3. Differentiate this, negative 5x to the power of negative 3 over 2 minus x to the power of negative 4 over 3. This is the same as negative 5 over x to the power of 3 over 2 minus 1 over x to the power of 4 over 3. This is the same as negative 5 over square root x to the power of 3 minus 1 over cube root x to the power of 4. Questions E. First, we're going to expand this. This is equal to x to the power of 4 minus 3x plus 9 over x squared. This is also equal to x to the power of 4 minus 6x plus 9x to the power of negative 2. Differentiate this, we're going to get 4x cubed minus 6 minus 18x to the power of negative 3. This is equal to 4x cubed minus 6 minus 18 over x to the power of 3. As square root of x is x to the power of 1 over 2, then I can write this as 8x squared over x to the power of 1 over 2 plus x over x to the power of 1 over 2. Now, using the law of indices, this is equal to 8x 2 minus 1 over 2 plus x 1 minus 1 over 2. The answer will be 8x to the power of 3 over 2 plus x to the power of 1 over 2. Differentiate this, we're going to get 12x to the power of 1 over 2 plus 1 over 2x to the power of negative 1 over 2. This is equal to 12 square root x plus 1 over 2x to the power of 1 over 2. So the final answer will be 12 square root x plus 1 over 2 square root x. Questions G. This is the same as 4 over 9 x to the power of negative 3 minus pi x plus 6. Differentiate this, we're going to get negative 4 over 3 x to the power of negative 4 minus pi. This is the same as negative 4 over 3x to the power of 4 minus pi. Question H. This is the same as x to the power of 1 over 2 times 2 minus x. Expand this, 2x to the power of 1 over 2 minus x to the power of 3 over 2. Differentiate this, you're going to get x to the power of negative 1 over 2 minus 3 over 2 x to the power of 1 over 2. This is equal to 1 over x to the power of 1 over 2 minus 3 over 2 square root x. So the final answer will be 1 over square root x minus 3 over 2 square root x. Question number 2. If f of x equal to 3x to the power of 2 over 3 plus 6x to the power of negative 1 over 3, finds the value of the first derivative of f of x. The first derivative of f will be 3 times 2 over 3 x to the power of 2 over 3 minus 1 plus 6 times negative 1 over 3 x to the power of negative 1 over 3 minus 1. Next, we're going to get 2x to the power of negative 1 over 3 minus 2x to the power of negative 4 over 3. This is the same as 2 over x to the power of 1 over 3 minus 2 over x to the power of 4 over 3. This is the same as 2 over cube root of x minus 2 over cube root of x to the power of 4. To find the value, now we need to substitute the x here with 8. This is equal to 2 over 2 minus 2 over 16, which is the same as 1 minus 1 over 8. Then the answer will be 7 over 8. Question number 3. Given f of t equal to 6t cubed over cube root of t. A. Simplify f of t. For the part cube root of t, I can write this as t to the power of 1 over 3. Now, using the indices law, I can write this as 6t to the power of 3 minus 1 over 3. So the answer of this is 6t to the power of 8 over 3. Questions B. Find the first derivative of f. This is equal to 6 times 8 over 3 t to the power of 8 over 3 minus 1. This is equal to 16t to the power of 5 over 3. Question C. Finds the value of the first derivative of f of 1 over 8. So here we're going to substitute the t here with 1 over 8. This is equal to 16 times 1 over 32. Then the answer is equal to 1 over 2. Question number 4. Given s equal to 3t squared plus 5t minus 7. Find the SDT and the range of the value of t such that the SDT is negative. So here the SDT is equal to 6t plus 5. Next, the SDT is negative. Any value that is less than 0 will be negative. So here the SDT is negative is the same as the SDT is less than 0. To find the range, we're going to substitute the SDT with 6t plus 5. This is equal to 6t less than negative 5. Then t is less than negative 5 over 6. Question number 5. Given dy dx for the functions y equal to ax cubed plus bx squared plus 3 at the point 1, 4 is 7. Finds the value of a and b. So here the gradient of the tangent at the point 1, 4 is equal to 7. To get the value of 7, we need to substitute the x coordinates, which is 1, into the dy dx. First, we're going to find the dy dx. This is equal to 3a x squared plus 2bx. Next, substitute the x here with 1, then the answer is equal to 7. Then we will get the equations of 3a plus 2b is equal to 7. So here we have two variables. To solve this, we need to get another equations. What we can do is substitute the coordinate of 1, 4 into these functions, as the point 1, 4 is one of the points of the functions. This is equal to a plus b equal to 4 minus 3, which is 1. So now we're going to solve for these two equations. So here we're going to solve these simultaneous linear equations using the eliminations method. So first label this as equations 1 and 2. So here I'm going to eliminate the b. Therefore, for the equations number 2, I need to multiply it by 2. Then I will get 2a plus 2b equal to 2. And I'm going to label this as equation 3. To eliminate the 2b, here I'm going to use equation 1 minus equation 3. Then a is equal to 5. To find the b, substitute a equal to 5 into equations number 2. Or if you want to substitute into equations number 1, also can. Then b is equal to 1 minus 5, which is negative 4. Question number 6. Finds the coordinates of a point for the functions y equal to x cubed minus 3x squared plus 6x plus 2 such that dy dx is 3. To find the dy dx equal to 3, we need to substitute the x coordinate of that point into the dy dx. First, find the dy dx. This is equal to 3x squared minus 6x plus 6. And this is equal to 3. So this is a quadratic equation. To solve this, write this in general form. 3x squared minus 6x. So here 6 minus 3 is positive 3 equal to 0. Next, we can simplify this by dividing every term with 3. X squared minus 2x plus 1 equal to 0. Using factorizations, we're going to get x minus 1. Another bracket will be x minus 1 as well. Therefore, the value of x is equal to 1. And this will be the x coordinates of that point. Then, to find the coordinate y, we need to substitute the x equal to 1 into the functions. Add the x here. Then, y is equal to 6. Therefore, the coordinates of that point will be 1, 6. Question number 7. Given the function h of x equal to kx cubed minus 4x squared minus 5x, finds a, the first derivative of h in terms of k. This is equal to 3k x squared minus 8x minus 5. Questions b. Finds the value of k if the first derivative of h with the input of 1 is equal to 8. So here we're going to substitute the x here with 1. This is equal to 3k minus 13 equal to 8. Then 3k is equal to 8 plus 13, which is 21. Then k is equal to 21 divided by 3, which is equal to 7. Questions number 8. Finds dy dx for each of the following functions. Here we can solve this using the chain rules or using this one. There is no need for us to use the product rules here, as the coefficients given here is just a constant without the variable x. Then this is equal to 3 over 4 times 4, bracket x over 6 minus 1 to the power of 3, and differentiate the terms in the bracket, which is going to be 1 over 6. So here we can simplify the 4 here and the 3 with the 6 here. Then this is equal to 1 over 2 x over 6 minus 1 cube. Questions b. dy dx is equal to 1 over 12 times 6 bracket 10x minus 3 to the power of 5. Then differentiate the terms in the bracket, which is equal to 10. So here we can simplify the 6 with the 12 and then the 2 with the 10 here. Then this is equal to 5 bracket 10x minus 3 to the power of 5. Question C. We can also write this as 8 bracket 2 minus 5x to the power of negative 1. Then dy dx is equal to 8 times negative 1 bracket 2 minus 5x to the power of negative 2. Then differentiate the terms in the bracket, which is going to be negative 5. Next, multiply the 8 with the negative 1 and negative 5, which is equal to 40. As for this part, to write the power as positive, then the answer will be 40 over bracket 2 minus 5x to the power of 2. Questions D. dy dx is equal to 3 bracket x minus 1 over x to the power of 2. Then differentiate the terms in the brackets. So here the terms in the brackets is the same as x minus x to the power of negative 1. To differentiate this, we're going to get 1 plus x to the power of negative 2. Next, for this part, we can write this as 1 over x squared. Questions E. I can write this as 1 over 3 minus 9x to the power of 1 over 3, which is the same as 3 minus 9x to the power of negative 1 over 3. Then dy dx is equal to negative 1 over 3 bracket 3 minus 9x to the power of negative 4 over 3. Then differentiate the terms in the bracket, which is negative 9. So here simplify the 3 and the 9. Then negative 1 times negative 3, we're going to get positive 3 over 3 minus 9x to the power of 4 over 3. This is the same as 3 over cube root of 3 minus 9x to the power of 4. Questions F. I can write this as bracket x squared plus 6x plus 6 to the power of 1 over 2. Then dy dx is equal to 1 over 2 bracket x squared plus 6x plus 6 to the power of negative 1 over 2. Then differentiate the terms in the bracket, which is equal to 2x plus 6. So here we can simplify the 2 with the 2 here and the 6. This is equal to x plus 3 over x squared plus 6x plus 6 to the power of 1 over 2. This is also the same as square root x squared plus 6x plus 6. Questions number 9. If y equal to 24 over 3x minus 5 squared, finds the value of dy dx when x equal to 2. So here I can also write this as y equal to 24 bracket 3x minus 5 to the power of negative 2. Differentiate this, we're going to get 24 times negative 2, 3x minus 5 to the power of negative 3. Then differentiate the terms in the bracket, which is 3. Then multiply 24 with negative 2 and 3, which is equal to negative 144. I can also write this as negative 144 over 3x minus 5 cubed. To find the value of dy dx when x equal to 2, just substitute the x here with 2. This is equal to negative 144 over 1 cubed. So the answer is negative 144. Questions number 10. Finds the value of constant a and constant b such that differentiating 1 over 3x minus 2 cubed is equal to negative a over 3x minus 2 to the power of b. First, we're going to differentiate this and then compare the answer. This is the same as differentiating 3x minus 2 to the power of negative 3. When we differentiate this, we're going to get negative 3 bracket 3x minus 2 to the power of negative 4. Then differentiate the terms in the bracket, which is going to be 3. So here negative 3 times 3 is going to be negative 9. Then the answer will be negative 9 over 3x minus 2 to the power of 4. So now by doing comparison with the answer given, then A is equal to 9. Then B is equal to 4. Questions 11. Differentiate each of the following with respect to x. Questions A. As this is the products of algebraic expressions, To differentiate it, we're going to use the product rule. So first copy the u for x, then differentiate the v. It will be 5 brackets 2x minus 1 to the power of 4. Then differentiate the terms in the bracket, which is going to be 2, plus copy the v, 2x minus 1 to the power of 5. Then differentiate the u, which is 4. Multiply 4x with 5 and 2. This is equal to 40x, and copy the rest. For these two terms, we're going to find the common factor. So first look at 40x and 4. The common factor will be 4. As for these two brackets, the common factor will be the bracket with a lower power, which is going to be power of 4. Next, we can start factorizing this. For the first term here, this common factor we need to multiply by 10x. And to get the second terms here, then this common factor need to multiply by 2x minus 1 to the power of 1. Next, solve this bracket. This will be 12x minus 1. As we cannot factorize this further, then this will be the answer. Questions B. To differentiate this, we're going to use the product rule. First, copy the u, which is x to the power of 4. Then differentiate the v. This will be 7 brackets 3x plus 1 to the power of 6. Then differentiate the terms in the bracket, which is going to be 3. Plus, copy the u, 3x plus 1 to the power of 7. Then differentiate the u, which will be 4x to the power of 3. Next, multiply x power of 4 times 7 and 3, which is equal to 21x to the power of 4. And copy the rest. Next, we're going to find the common factor of these two terms. For 21x to the power of 4 and 4x cubed, the common factor will be x cubed. And for this bracket, the common factor will be 3x plus 1 with a lower power here, which is going to be 6. So now we can start factorizing this. To get the first term, then this common factor, we need to multiply by 21x. And to get the second terms here, then this common factor need to multiply 4, then bracket 3x plus 1 to the power of 1. The bracket here, we're going to get 21x plus 12x plus 4. Then the answer for the bracket here will be 33x plus 4. As we cannot factorize this further, then this will be the answer. So for the square root here, I can also write it x bracket x plus 3 to the power of 1 over 2. To differentiate this, we're going to use the product rule. First, copy the u, which is x, then differentiate the v. This is equal to 1 over 2 bracket x plus 3 to the power of negative 1 over 2. Then differentiate the terms in the bracket, which is going to be 1. Plus, copy the v, square root x plus 3. Then differentiate the u, which is 1. Next, we're going to get x over 2 bracket x plus 3 to the power of 1 over 2. So this is also equal to square root x plus 3. Then plus square root x plus 3. To solve this, first we will need to equalize the denominator. So next we're going to get x plus 2 bracket x plus 3 over 2 times square root x plus 3. So for the numerator, we're going to get x plus 2x, which is going to be 3x. And 2 times 3 going to be 6. And for the numerator, we can factorize it. The common factor is 3 bracket x plus 2 over 2 square root x plus 3. Questions D. To differentiate this, we're going to use the product rule. First, copy the u, x plus 7 to the power of 5. Then differentiate the v, which is going to be 3 brackets x minus 5 to the power of 2. Then differentiate the terms in the bracket, which is going to be 1. Plus, copy the v, x minus 5 to the power of 3. Then differentiate the u. This will be 5 brackets x plus 7 to the power of 4. Then differentiate the terms in the bracket, which is going to be 1. Next, we're going to get 3 brackets x plus 7 to the power of 5 times x minus 5 to the power of 2 plus 5 x plus 7 to the power of 4 times x minus 5 to the power of 3. Next, we're going to find the common factor of these two terms. So first, look at the bracket x plus 7. The common factor will be x plus 7 with a lower power here, which is going to be 4. As for x minus 5 here, the common factor will be x minus 5 with a lower power, which is going to be 2. So now we can start factorizing this. To get the first terms here, then this common factor will need to multiply by 3 and x plus 7 to the power of 1 plus, to get the second terms here, then this common factor will need to multiply by 5 and x minus 5 to the power of 1. Expand the bracket, we're going to get 3x plus 21 plus 5x minus 25. Solve the bracket, we're going to get 8x minus 4. So for 8x minus 4, we can factorize this. The common factor will be 4. Then this will be 4 bracket 2x minus 1. And if we rearrange this, then this will be the answer. Questions E. As this involves the quotients of algebraic expressions, to differentiate this, we're going to use the quotient rule. First, for the square root x, I can write this as 1 minus x to the power of 1 over 2 over 1 plus x to the power of 1 over 2. To differentiate this, first copy the v, 1 plus square root x, then differentiate the u, which is equal to negative 1 over 2 x to the power of negative 1 over 2 minus the u, which is 1 minus square root x. Then differentiate the v, which is 1 over 2x to the power of negative 1 over 2 over v squared, 1 plus square root x squared. For this part, I can write this as negative 1 plus square root x over 2x to the power of 1 over 2. And for the x to the power of 1 over 2, I can write this as square root x. Then minus this part, which is equal to 1 minus square root x over 2 square root x. So for the numerator part here, to minus this, the denominator already the same. Therefore, we can solve it straight away. This will equal to negative 1 minus square root x minus 1 plus square root x over 2 square root x. And for the part divided by v squared, I can write this as multiply 1 over 1 plus square root x squared. So here the negative square root x plus square root x will be cancelled. What left will be negative 2 over 2 square root x times 1 plus square root x squared. So here we can simplify it for the 2. Then the answer will be negative 1 over square root x times 1 plus square root x squared. Questions F. For the part square root here, I can write this as x over 4x plus 1 to the power of 1 over 2. Using quotient rule, first copy the v, square root 4x plus 1, then differentiate the u, which is equal to 1, minus copy the u, which is x, then differentiate the v. This is equal to 1 over 2 bracket 4x plus 1 to the power of negative 1 over 2. Then differentiate the terms in the bracket, which is going to be 4 over v square. So square root 4x plus 1 square. Next, we're going to get square root 4x plus 1 minus this part, which is going to be 2x over 4x plus 1 to the power of 1 over 2, which is the same as square root 4x plus 1. So for the denominator part here, using the indices law, this will be equal to 4x plus 1. To solve for the numerator part here, we will need to equalize the denominator. So here we're going to get 4x plus 1 minus 2x over square root 4x plus 1. For the part divided by 4x plus 1, I can write this as 1 over 4x plus 1. Solve this part, then we're going to get 2x plus 1. So for this part, using this indices law, this is what we're going to get. Then I can write this as square root 4x plus 1 cubed. Questions G. So here we're also going to solve this using the quotient rule. First, copy the v, x squared plus 2x plus 7. Then differentiate the u. The answer here will equal to 0. Then minus u, which is 1. Then differentiate v, which is 2x plus 2 over v squared. So x squared plus 2x plus 7 squared. This part here is equal to 0. And for this part, for the 2x plus 2, we can factorize it. The common factor will be 2. Then we're going to get negative 2 bracket x plus 1 over x squared plus 2x plus 7 squared. Question H. This will be the u and v. Using quotient rule, first copy the v, x minus 1, then differentiate the u, which is negative 6x squared, minus copy the u, 1 minus 2x cubed. Then differentiate the v, which is 1, over v squared, x minus 1 squared. For the numerator part, expand it, you're going to get negative 6x cubed plus 6x squared minus 1 plus 2x cubed. Solve this, then we're going to get 6x squared minus 4x cubed minus 1 over x minus 1 squared. Question 12. Show that if f of x equal to x times square root x squared plus 3, then the first derivative of f is equal to 2x squared plus 3 over square root x squared plus 3. As this is the product of algebraic expressions, to find the first derivative, we're going to use the product rule. So for fx, this is the same as x times x squared plus 3 to the power of 1 over 2. So here, first copy the u, which is x, then differentiate the v. This is equal to 1 over 2 bracket x squared plus 3 to the power of negative 1 over 2. Then differentiate the terms in the brackets, 2x. Then plus the v, x squared plus 3 to the power of 1 over 2. Then differentiate the u, which is 1. So here we can cancel the 2. So for this part, x times x, we're going to get x squared over x squared plus 3 to the power of 1 over 2 plus x squared plus 3 to the power of 1 over 2. So for these two, I can also write this as square root x squared plus 3. To solve this, we will need to equalize the denominator. Here we're going to get x squared plus x squared plus 3 over square root x squared plus 3. Then this is equal to 2x squared plus 3 over square root x squared plus 3. Questions number 13. Given y equal to 4x minus 3 over x squared plus 1, find dy dx and determine the range of the values of x such that all the value of y and dy dx are positive. To find the dy dx, here we'll need to use the quotient rule. First, copy the v, x squared plus 1, then differentiate the u, which is 4, then minus the u, 4x minus 3, then differentiate the v, which is 2x, over v squared, x squared plus 1 squared. So for the numerator part, expand it, 4x squared plus 4 minus add x squared plus 6x. Solve the numerator, then we're going to get 4 minus 4x squared plus 6x over x squared plus 1 squared. So here dy dx are positive. This means dy dx is greater than 0. Therefore, this part is greater than 0. To find the range of value of x, move the denominator to the right hand side. This will greater than 0, as anything multiplied by 0 is 0. So this is quadratic inequalities. First, I'm going to divide every term with negative 2, so that my a will be positive. And arrange this, then I'm going to get 2x squared minus 3x minus 2 less than 0. So here the inequality signs will be reversed as we divide it with a negative number. Factorize this, then we're going to get x minus 2, 2x plus 1 less than 0. So based on the factorizations, the value of x will be 2 and negative 1 over 2. So here will be negative 1 over 2 and this will be 2. As this is less than 0, then we're going to shade the area below the axis. Then the range of value of x will be x greater than negative 1 over 2 less than 2. We are not done yet, as the question stated that all the values of y are positive. This means y is greater than 0, which means this part will greater than 0. To solve this, move the x squared plus 1 to the right hand side. Then 4x minus 3 is greater than 0. X is greater than 3 over 4. So here we have two range of value of x. To find the range of value of x that satisfies y and dy dx are positive, then here I'm going to use the number line. So for the range x greater than 4 over 3, it will be on the right hand side. For the range x greater than negative 1 over 2 but less than 2, it will be the value in between this. So for the part that satisfies these two range, it will be in between 3 over 4 and 2. Therefore, the final answer for the range of value of x will be x greater than 3 over 4 but less than 2. Questions 14. Given y equal to x minus 2 over x squared plus 5, finds the range of the value of x such that y and dy dx are both negative. To find dy dx, here we're going to use the quotient rule. First, copy the v, x squared plus 5, then differentiate the u, which is equal to 1, minus u, x minus 2, then differentiate the v, which is 2x, over v squared, x squared plus 5 squared. Next, expand for the numerator, x squared plus 5 minus 2x squared plus 4x. Solve the numerator, then we're going to get 5 minus x squared plus 4x over x squared plus 5 squared. So here the conditions is dy dx is negative, which means dy dx is less than 0. Therefore, this is less than 0. To solve this, move the denominator to the right hand side. This is less than 0, as anything multiplied by 0 is 0. This is quadratic inequalities. So here I'm going to divide every term with negative 1 so that my a will be positive. And I'm going to rearrange this. Then this is equal to x squared minus 4x minus 5 greater than 0. The inequality signs will be reversed as we divide by negative number. Factorize this, then we're going to get x minus 5, x plus 1 greater than 0. Based on the factorizations, the value of x is 5 and negative 1. So here will be negative 1 and this will be 5. As the quadratic inequalities is greater than 0, then the range will be above the x-axis, which is going to be these two parts here. For this part, the range will be x less than negative 1. As for this part, the range will be x greater than 5. Here we have another condition is that y are also negative, which means y is less than 0. Therefore, this part here is less than 0. To solve this, move x squared plus 5 to the right hand side. Then we're going to get x minus 2 less than 0. X is less than 2. To find the range of the value of x that satisfies y and dy dx are both negative, we're going to write these three range on the number lines. For the range x less than 2, it will be on the left hand side of 2. For x less than negative 1, it will be on the left hand side of negative 1. And for the range x greater than 5, it will be on the right hand side of 5. Based on the diagrams, the range of the value of x that satisfies y and dy dx are both negative will be here. Therefore, the final answer for the range will be x less than negative 1.